This is Ham College, episode 60 for December 31st, 2019. Ham College is brought to you by ICOM. Wish it, wrap it, gift it. Step up your gift-giving game this year and get your favorite ham, the transceiver, at the top of their list. And by hamstudy.org, a great place to study for your next amateur exam. Good evening and welcome to another episode of Ham College. I'm Professor Thomas.
And I'm Dean Martin.
And tonight is going to be our last show covering the General Amateur Radio exam.
Oh, wow. Going to have to get the thinking caps out after this one.
It's the last show of 2019. We'll be starting out with Extra in 2020. I don't know, next month if we are, next year.
That too.
Choose A, B, or C. Choose either one you want there. Anyway, the next episode, I don't know if we should maybe do some review or hone up on test-taking skills, or if we should just jump right on in both feet into the extra pool.
Or maybe a little bit of both.
I like that. I mean, jumping in, I'd rather just stick my toe in that extra pool to start with and see how cold it is.
See if it's hot. Yeah. You don't want to scald yourself.
No. You don't want to pull a Chevy Chase either.
Dark hole! Jesus! Yeah, speaking of that, every time we do the I'm Professor Thomas and I'm Dean Martin, and I always want to do I'm Dean Martin and you're not. You remember the Chevy Chase thing? I'm Chevy Chase and you're not.
Yeah.
Let's turn to the news. Of course, that was Les Nessman.
You could do that too.
Yeah. I can't. I'm wired in. I'll hang myself with this wire.
Oh, okay. Yeah, there's a number of you who have told us in the last few weeks that it's about time that you upgrade to extra, and not you. I mean them.
The other.
They're about ready to upgrade to extra, so they'll be paying attention in class this time around.
Yeah, no sleeping.
No
Not going to be able to sleep through class for that one and pass.
Nope. You could miss some mighty good bloopers and some mighty good wrong answers too.
Fun. A lot of fun.
The faculty will even have an adventure in the extra here.
Mm-hmm. That's true.
Oh, let's see. Did I mention that we'll be doing a New Year's Eve show?
I don't know if you mentioned it since we started streaming or not.
I did.
Be a good time for it.
It would be a good time for it. We'll be doing a New Year's Eve live stream again this year, starting at 9 p.m. in
Central Time.
Central Time, yeah, that's 0200 UTC, and going until we quit, which will be sometime after midnight. And what day are we doing that?
Let's see, that would probably be the day before New Year's Day.
That's
New Year's Eve.
That's a Tuesday.
Yes, that's this coming Tuesday.
This coming Tuesday.
And I believe that's the 31st.
I believe you're right.
31st of December. 2019.
Yeah. So you guys, in the true spirit of Glenn, I don't know if Glenn's in the chat room yet tonight.
No, I don't see Glenn.
Last year, Glenn was in the chat room during the New Year's Eve stream, and he coined a phrase that I think most of us live by, and that was, do you remember that phrase?
No, I don't. But I will after you tell me, I'm sure.
We thanked everyone for being there for the live stream, and he says, we weren't doing anything anyway. That's why we're here.
Oh, that's, I do remember that.
So That has become a real classic.
It's hard
around
to
here.
it's hard to argue with logic like that.
Yeah. Well, you never know. He does hang out with Emil some,
Yeah,
and he knows how to eat crawfish. So,
he does have that down.
yep. The guy's got skills, mad skills.
Mad skills.
Anyway, maybe he'll show up here in the chat room a little bit. I guess we should get on into them. We've got, I believe it's 22 questions tonight. So, yeah, we're going to have to get on in there and get started with some of these.
Got the buzzer all charged up?
The buzzer is charged. It kind of ran down after the last episode.
Yeah, well, it's probably going to get a workout this time too. We got an extra battery.
Yeah, it needed a good recharge. Anytime we're doing a show, we've been talking about the chat room here. Well, while we're live, we've got a chat room going on. You can join right there if you're watching on the live stream, AmateurLogic.TV/chat.
Yep. If you're watching the live stream and you're not in the chat room, you're missing half the fun. Your turn.
But which app? That's the question.
That's up to you to decide that. I'll ask the first one this time. You normally go first.
Okay.
Which type of rectifier circuit uses two diodes and a center tapped transformer? A, full wave.
B, full wave bridge.
C, half wave.
Or D, synchronous. Which type of rectifier circuit uses two diodes and a center tapped transformer? Well, I know the answer to this one.
Yeah, I figure you did.
Because I have built a bunch of these, and I've worked on a bunch of them that had two diodes go bad in them.
Oh, yeah?
Yep. I've worked in them that had one diode or even up to four go bad. Yeah, everybody's saying A, which is what I'm thinking here. It's a full wave rectifier. It's not a full wave bridge. Might be confused about that. A full wave bridge would use four rectifiers in there instead of just two.
Diodes?
Four diodes.
Oh, okay.
It's kind of drawn like a diamond, the four rectifiers.
Yeah, I remember we looked at those a few months back. I think we had a little schematic up there about them.
What is an advantage of a half-wave rectifier in a power supply? Is it A, only one diode is required?
B, the ripple frequency is twice that of a full wave rectifier.
C, more current can be drawn from the half-wave rectifier.
Or D, the output voltage is 2 times the peak output voltage of the transformer. And me with my horrible memory, if the full wave rectifier had 2 diodes, I'm going to venture to say that the half wave rectifier has 1 diode. So I'm thinking the answer is A, but let's run down through the other ones just to be sure.
And that's an advantage?
Yeah. Well, it's less components.
There you go, A.
Hey.
There's your ceremonial fist bump.
Canadian answer.
Yeah. Of course, Mike got that one right.
For which of the following modes is a Class C power stage appropriate for amplifying a modulated signal? A, single sideband.
B, FM.
C, AM.
Or D, all these choices are correct. For which of the following modes is a Class C power stage appropriate for amplifying a modulated signal? Well,
I'm glad you got this one.
Yeah, I know the answer to this one.
I figured you probably do.
Yeah. And let me tell you why I'm going to choose the answer I'm going to choose here.
That would be good.
There are a number of different classes of amplifiers. They're all to do with the bias and how long of a period the amplifier is shut off. That'll affect the efficiency of the amplifier. A Class A amplifier is going to be, well, you might say that's the highest class. It's going to have the purest signal. at the same time, though, it's going to draw the most power and be the least efficient of all of them because it's so accurately reproduces the output. The Class B, you'll sacrifice a little bit of purity in the signal in exchange for some efficiency. A Class C, now you're getting more efficient, a lot more efficient than, say, a Class A amplifier would be. But you're adding more distortion to that signal. And some places that's not just going to work out. I'm going to say it's definitely not D. And let's look at the other answers here. AM, C. That's not correct because AM is amplitude modulation. That signal that you're amplifying, it has to faithfully reproduce what you put in. Mm-hmm. So if you're using a Class C, you're adding distortion to it, so it wouldn't be a good choice for AM. Let's see. A, single sideband. Well, you know, for single sideband and AM, we have a name for the amplifiers that we might use to hook to our rig to get the power up. We use a linear amplifier. Mm-hmm. And, you know, a linear amplifier is going to be more like a Class A amplifier than a Class C. Because single sideband, you need to preserve that waveform that you're putting in when you amplify it. If you run it through an amplifier that adds distortion, you're distorting that signal. However, B, FM is going to be your answer, and that's because the modulation on FM is what? It's frequency modulation. So the amplitude of that signal doesn't really affect the modulation so much. I mean, yeah, there might be a little amplitude changes with modulation, but that's not what we're looking for to transfer the signal. We're changing the frequency, and which would be, you know, more in a horizontal than a vertical format. And a Class C amplifier, although it might add a little distortion to the amplitude of the signal, it's not going to matter so much for FM because we're not looking for how clean the carrier is. We're just looking to see if it changes the frequency, and that's what gives us our modulation. So I'm going to say it's B, FM. And I lucked out on that one, although I didn't know the answer. I'm not sure
that was luck.
Yeah.
But that was a good explanation there, Professor.
Well, thank you. I was hoping I could get by with that. So, and it looks like most people got that right over in the chat room too. So, I've got another one for you.
Okay.
What is the phase difference between the I and Q signals that software-defined radios, SDR, equipment uses for modulation and demodulation? Is it A, 0?
Ooh. B, 90 degrees?
C, 180 degrees?
Or D, 45 degrees? What is the phase difference between I and Q? Software-defined radio uses for modulation and demodulation. I'm going to have to guess on this one because I honestly don't know. And nobody in the chat room's putting anything down there.
Yeah, I notice you keep looking over there. You can't rely on them on this one. Can I give you a clue?
Sure, please do.
And you probably already know this. You know, we typically on a homemade software-defined radio anyway, we're using a stereo sound card in there, and we're sending a signal into it. We're sending one signal to the left channel and one to the right. One of those signals is the I signal, and the other signal is the Q signal. And that's all the hint I'm going to give you. So that really wasn't a very good hint, was it?
No, it wasn't. I'm just going to guess. All I know to do is guess, and I'm thinking it might be 90. I kind of want to say C, 180, but typically if things are out of phase like that, one cancels the other out, but I don't understand how this is actually being used, so I'm gonna guess B, but I'm probably wrong.
Well, they're a little mixed in there in the chat room on this one. Some people got it right and some got it wrong.
If you pick 180 degrees, it seems like that would be the same as a pair of noise canceling headphones.
Yeah, I think a lot of the folks are not answering this one.
I don't blame them. I plead the fifth also.
Well, I'm going to agree with you. I'm going to say it's B.
Really?
And it is.
Well, I wanted to say C, but then I got thinking
I was
about
hoping you
canceling
would.
out.
Yeah, but you didn't.
So 90 degrees seemed like the obvious choice, but I don't know why it's 90 degrees. That was just a guess.
Okay. Well, I should probably ask you this next question then.
I should buy a lottery ticket.
Yeah, this time would have worked for you.
What is an advantage of using, here we go, of using I and Q signals in software-defined radios, or SDRs? A, the need for high-resolution analog to digital converters is eliminated.
B, all types of modulation can be created with appropriate processing.
C, minimum detectable signal level is reduced.
D, converting the signal from digital to analog creates mixing products. What is an advantage of using I and Q signals in software-defined radios? I know the answer to this one.
I'm going to guess on this one. I'm guessing it's B.
You know, that is a pretty good guess, Dean.
Well, it seems to make sense to me in my twisted mind.
Well, most people are saying B over in the chat room. Their answers are still coming in on this one. I'm going to say it's B. All types of modulation can be created with appropriate processing. And, you know, if you think about it, that makes sense. This probably won't show up. No, it won't. So
you can see it.
You think?
Yeah.
All right. Yeah, you can't see it very well. I don't know if you can see it well enough for me to explain it.
Yeah.
Anyway.
Yeah, just don't move it.
I just can't draw from the back side of the paper. Here, let me draw.
I'll hold it and then
I'll draw something on it.
Whatever happened to your little welcome tablet?
It's over here and it's just not plugged in.
M?
It's a sine wave. And on the X and Y axis here, if you had an I and a Q signal, one represents the amplitude, one represents the phase, you could reproduce any point on there. You could identify any point in this sine wave by telling me what the value of the amplitude and the phase would be. I could say that is right there. So you could reproduce any signal that you could, any type of modulation that you could come up with. Make sense?
Yeah. Yeah, pretty much.
Okay. Good. I was hoping.
Pretty amazing stuff, man.
I was hoping that was the right answer. No, that is pretty amazing stuff, and that's why it's 90 degrees, because, you know, those two axes there are at 90 degrees from each other. What type of modulation is used by the FT8 digital mode? Is it A, 8-tone frequency shift key?
B, vestigial sideband. I probably butchered that.
Vestigial.
Vestigial sideband.
C, amplitude compressed AM.
D, direct sequence spread spectrum. I'm going to go straight for the throat on this one.
Okay.
But I've actually been playing around with this week, so I'm pretty sure the answer is going to be A, 8-tone frequency shift key in FSK.
You're on for a guy who didn't know the answers tonight, you're on a pretty good roll here.
Well, I've been playing with this week.
Yeah.
I've told you about that.
Did you see 8 tones in there?
No, but I knew it was frequency shift key, and I don't see any other ones on there.
Yeah, everybody's saying A over there in the chat room. You're right. 8-tone frequency shift key. I didn't know it was 8 tones, but I knew it was FSK.
Well, then you'd have probably got it right too then, wouldn't
Yeah.
you?
And, well, I would have got it right because I knew it wasn't vesicle sideband. That was something we used in the old NRSC analog television.
Yeah, I knew the other ones weren't right, too.
Yeah, amplitude compressed AM. Now, direct sequence spread spectrum. I mean, we're just using a little tiny little part of the spectrum for FT8, so you know that.
Very tiny.
Yeah, that can't be it. Well, we managed to get through those so far.
Yeah, almost unscathed. Actually.
We did.
Yeah, we hadn't had a buzzer yet.
Yeah.
I was expecting one, too.
Oh, it could
I
happen.
probably deserved one.
We've been through 1/3 of the questions now.
So you're saying there's a chance?
I'm saying I've saved one up for you.
Okay.
All right, we'll be back in just a moment. Don't go away, because like I say, we're only 1/3 of the way through these questions. New year, new savings. Bring in the new year loud and clear with some of ICOM's most innovative products. Check out the ICOM America website for current promotions on ICOM 7610, 7300, and 9700. Start the year off right with the high-performance IC 7610, a direct sampling transceiver that will change the world's definition of SDR. It has the ability to pick out the faintest signals even in the presence of stronger adjacent signals. RF direct sampling system, 110 RMDR, independent dual receivers, and dual digicell. With the IC 7300, ICOM is changing the way entry-level HF is designed. High-performance, innovative HF transceiver with a compact design that will far exceed your expectations. RF direct sampling, 15 discrete bandpass filters, large 4.3-inch color touchscreen, real-time spectrum scope, and SD memory card slot. The IC 9700 was built with the VHF-UHF weak signal operator in mind. Faster processors, higher input gain, higher display resolution, and a cleaner signal. ICOM's IC 9700 is the pinnacle of perfection. 4.3-inch color touchscreen, dual watch operation, and full duplex operation in satellite mode, real-time high-speed spectrum scope and waterfall display, voice recording playback functions with SD memory card, supports CW, AM, FM, single-sideband RIDI, and D-Star DV and DD modes. Visit ICOMAmerica.com/amateur for more information and current promotions on ICOM 7610, 7300, and 9700. And thanks, ICOM, for sponsoring Ham College here. You know, we should probably...
Yeah.
I don't know where I was going with that.
We should probably give away this hat.
We should probably give away that hat.
And while we're at it, what about this extra t-shirt I got right here?
Well, that is an extra t-shirt. How could we give something like this away?
Well, if somebody wanted to enter the contest, all they've got to do is have a name and an email address. Pretty much it.
That's pretty low bar.
It is. So you can send an email to hamcollege@AmateurLogic.TV, and if you want to write a little comment in there, that's great. We appreciate reading them. But if not, just send that in, and you'll be in the drawing to win it next. Yeah, I said next year.
Yeah,
but I was right.
Yeah.
Next month and next year, same thing.
Because you have to re-enter every month. We don't save the entries.
And what is it I tell you about the front and the back?
You say you look as good coming as you are going, and you actually got to use that joke tonight.
My wife, when I was leaving, she said, "Hey, hang on a minute. Didn't you have your shirt on backwards?" so I actually got, so I turned around and showed her it was the same on the front, and I actually got to use that line on her today.
You know, it's not every day that you have opportunity to use a line like that.
She's pretty good to me, but that wasn't an intentional setup. She didn't know the routine. She's not a viewer of Ham College, although she should be. But anyway, let's see who won.
Well, tonight's lucky winner is Don KD9FHJ, and Don said, "Hello. Beginning to study for my general and found your channel on YouTube. Thank you for sharing your ham knowledge, humor, and encouraging others to get their licenses." And congratulations, Don. you're going to look as good coming as you do going now.
Absolutely.
Just like the dean said here.
Yep. And if anybody asks you if you got your shirt on backwards, you can use that line. Feel free to use it just like it was your own.
You didn't copyright it.
No, I didn't copyright it.
Okay.
It's free for all.
Okay.
So anyway, and I think I added her to the Facebook group not too long ago.
Cool.
Pretty sure.
All right. Well,
Anyway, congratulations.
She's got some episodes to catch up on there.
Yep.
And good luck in the test there.
Which mixer input is varied or tuned to convert signals of different frequencies to an intermediate frequency, or IF? A, image frequency.
B, local oscillator.
C, RF input.
Or D, beat frequency oscillator. Let me read that question again. Which mixer input is varied or tuned to convert signals of different frequencies to an intermediate frequency? It's not an image frequency. It's not A. It's not C, RF input. And it's not D, beat frequency oscillator. That only leaves local oscillator. And you know, local oscillator, that's kind of familiar sounding term there. And that just happens to be the way it works, is you have a local oscillator and you mix some signal from it with the RF input signal, the station you're trying to receive, and you can't change the frequency of the station you're trying to receive. It's just whatever frequency it is. But you change the frequency of that local oscillator, and when those two signals combine and mix, you've got a product of those out there that is detected, and that's kind of how a super heterodyne radio works with local oscillators. So I hope I'm right, because otherwise that's a long explanation to be wrong.
It's going to be kind of embarrassing after I explained all that wrong.
Yep. Everybody over in the chat room got it, though. Well, most everybody in the chat room.
Yeah, some of these are a little bit tough. These a lot of times when they amend the question pool, it's usually really minor stuff. But some of these are some new things I don't remember being in there before.
Yeah. We've actually talked about super heterodyne radios before, but they didn't use that
but
term
I don't remember
right here.
the SDR stuff.
I don't think. Yeah, I don't
that's
recall
the stuff that I was kind of concerned. Even though I do have SDR, I don't. Some of it up.
You don't know the phase difference of your I and Q signals. Well, actually, you
it's
do.
90 degrees.
Yeah.
Everybody knows that.
On what band?
Don't try to insult me.
On what band do amateurs share channels with the unlicensed Wi-Fi service? Is it A, 432 megahertz,
B, 902 megahertz,
C, 2.4 gigahertz,
or D, 10.7 gigahertz? And I do believe the answer to that is 2.4 gigahertz. I know that's Wi-Fi.
I'm going to agree with you.
There are a lot of things that share it. There's even some stuff going on with some of the 2.4 gigahertz controllers for drones now, that you have to have your call sign transmitted with the video signal, and you got to have obviously a ham license to have the call sign, but to be able to use that stuff nowadays. I'm not sure if they pushed that all into law yet, but I know they were talking about it.
Yeah. It's 2.4 gigahertz, but I just wanted to take a moment there, and I'm glad you did that explanation to let everybody get their answer in here, and everybody says it's C. Yeah, I think we all know that Wi-Fi is 2.4 gigahertz.
They've been copying off my paper. They all put C
They may.
in.
You think?
No.
There you go. The answer is C.
All right.
You got one for me?
Yeah, how about this one? Which digital mode is used as a low-power beacon for assessing HF propagation? A, WSPR or Wspr.
B, Olivia.
C, PSK31.
Or D, SSB-SC. Which digital mode is used as a low-power beacon for assessing HF propagation? I happen to know the answer to this one.
You know the answer to this
because
one. I know the answer to this one too, because I've been playing with this week too.
Well, I built one of these a while back. Now, as a matter of fact, I think I set at the time a world record.
Yeah. Oh, that's right. You sure did.
It's WSPR, and I didn't hang on to that world record maybe a day or so. Somebody else beat it. But it's WSPR, and I believe that is weak signal propagation report or reporter.
Yeah, I think that's right.
It's something close to that if that's not it. Let's see what everybody said in the chat room, though they all knew the answer too. WSPR.
Yeah, I've been playing with that a little bit this week too. Been actually getting a little radio time since I've been off work. It's been kind of nice.
The
I haven't used it in a while.
The thing about WSPR is it's just a real low power, the little transmitter, that you just sit there and it automatically sends out a beacon every so often. Just a little low power signal. Other people around the world have receivers set up listening, and if they hear your signal, they'll log it, and it'll be logged there on the internet, and you can go look, and it'll draw you a nice little map that shows everywhere that people heard your signal. And so you can look at different times of the days and on different days and see where your signal made it to, or who else's signal, is making it where. To give you an idea of how the propagation is in a particular direction on a particular band.
Yeah, I did it this morning on 40 meters. I pretty much had most of the U.S. covered up.
Really?
On it. Yeah, it was pretty crazy.
Boy, you on a roll, weren't you?
Yeah, it was. I guess the band was good this morning for some reason.
Sounds like you were having more fun than should be allowed.
No, it should be allowed. Should.
Of course, everybody got that right over in the chat room. What is a typical characteristic impedance of window line parallel transmission line? A, 50 ohms.
B, 75 ohms.
C, 100 ohms.
Or D, 450 ohms. And the typical characteristic impedance of window line parallel transmission line is going to be, I know it had really high impedance. It's going to be D, 450 ohms.
Okay.
I wanted to say, I seem to remember 300 ohms, but maybe that's the TV cable that I'm thinking of. But I think the answer is D, 450 ohms.
Well, I think you're right. Dean, you know so much on this subject here.
I can't even see the picture.
Why don't you do some splaining?
Yeah, that's a good picture of it right there. There's the two conductors. They're parallel, and the plastic spacers in between it, and then these are cutouts of the windows. And that's it in use.
Well, yeah, that is a type right there. That's a little unusual. That's homemade there.
That's ladder line.
Yeah.
But that would be window line right there.
And it's sort of like the old flat twin lead television cable. Very similar. It's just got the cutouts there and the insulation across the middle. And it's 450 ohms instead of 300. 300 is
twin lead
television.
Which of the following best describes the radiation pattern of a quarter wave ground plane? I'm sure that must say vertical.
Ground plane vertical antenna.
Yeah, what he said.
Yeah.
A, bidirectional in azimuth.
B, isotropic.
C, hemispherical.
Or D, omnidirectional in azimuth. Which of the following best describes the radiation pattern of a quarter wave ground plane vertical antenna? So that's going to be a vertical antenna with some ground counterpoise around the bottom of it. What would the radiation pattern be? Well, It's not bidirectional azimuth because it's the same all the way around it. And azimuth would be, going out from it. Elevation would be at an angle from it, going up or down. I don't think it's isotropic. It's not hemispherical. Is that what you said?
Mm-hmm.
It's omnidirectional in azimuth. It's the same radiation pattern all the way around it. D. That's my answer.
Final answer?
Yeah.
Okay.
That's what everyone's saying over in the chat room.
I would agree with that.
Yep. Well, I got one more for you here, and then we're going to take a quick little break.
Okay.
And we might have some entertainment.
We need some entertainment.
Yeah, there hasn't been any tonight.
No.
How do the lengths of a 3-element Yagi reflector and director compare to that of a driven element? A, the reflector is longer and the director is shorter.
B, the reflector is shorter and the director is longer.
C, they're all the same length.
Or D, relative length depends on the frequency of operation. How do the lengths of the 3-element Yagi reflector and director compare? Okay, so A, the reflector is longer, director is shorter. B, the reflector is shorter, director is longer. Or they're not all the same length, they're not C. Relative length, no, not the relative length that depend on the frequency of operation would affect all three, but not individually like the question's implying. So the answer is going to be A. I think the reflector is longer and the director is shorter.
That's what most of the people are saying in the chat room. I'll agree with you. The reflector is longer and the director is shorter.
And I built one out of a tape measure so I could tell you exactly how long.
Did you ever sell the other half of that tape measure? No,
I still got that other half of tape measure on eBay if anybody's interested in it.
Okay. All right. Well, we've got more questions to go yet, but let's take a quick break, get a message, stretch our legs, maybe go to the snack bar, and we'll be right back.
Sounds good.
Are you new to the ham world or an existing amateur operator who wants to take your license to the next level? Study for your radio license exam at hamstudy.org. Hamstudy.org is a free online learning tool powered by ICOM. It was created by Richard Bateman, KD7BBC, Michael Stufflebean, KV9G, and Rich Porter, KK6GKE, and it uses a modern web design to enhance the experience of studying for your technician, general, and amateur extra exams. Since 2013, hamstudy.org has helped new and existing hams to familiarize themselves with the question pools, use stats-based flashcards to focus on material they need to learn, and take practice exams to gauge progress. Visit hamstudy.org on your desktop computer or mobile device. Register for a free account at hamstudy.org to access personalized study history and other site features. Prepare for an exam in an intuitive and comprehensive manner. Check out hamstudy.org, powered by ICOM, for free learning tools. Good luck on your next exam.
Grown-ups get all the breaks.
Sure, but now you can have your own shooting gallery with the Electroshock Shooting Gallery by Marks. Feel the firepower. Squeeze off shot after shot with this electric rifle. And look, press the switch, and you've got a rapid-fire submachine gun. Reloads itself, too. And what a wild choice of targets. Bag a lion, if you dare. Clang the bell, if you can. Rock the Clown. But he's no pushover. The automatic scorekeeper shows you how sharp you are. Or are you? Try again. A bullseye. Pick off the revolving ducks. Watch them go down. Well, sometimes. Spin the Traveler. What a challenge for everyone. 8 wild, banging, spinning, bouncing, soaring targets. Get the Electroshot Shooting Gallery by Marks.
What you are about to see is top secret. The first official test of the powerful new Lionel turbo missile firing car. Right beside it stands the new Lionel reconnaissance copter car. Suddenly, its roof snaps open, and the reconnaissance copter zooms aloft to get range and position of targets. And there they are, on the other side of the firing range, a battery of new Lionel aerial target cars. Their air compressors holding the targets in place. And now, the test. Fire 1. Fire 2. Test successful. See the exciting new Lionel turbo missile firing car, aerial target car, and the reconnaissance copter car. Remember, boy, you're the boss of the greatest action cars ever created when you own Lionel trains.
Wow. I don't remember that.
The train?
The train. No.
No, I don't either. I've never seen that. I wonder how many times they shot that little propeller thing at those balloons to hit them.
Oh, it's no telling. And that was like magic, how the balloon just stayed right above the car as it moved along. I bet that took a little practice to get down too.
Yeah.
The shooting gallery, I want to say I had seen that before.
Yeah, I've heard of that.
Yeah. I think I have actually shot on one of those before.
Oh yeah?
Yeah. I don't remember if my brother had one or if it was maybe one of my friends. It's probably one of my friends, but I don't remember. Well, we got more questions here. You got more answers?
Yeah.
Okay.
Just like Home Depot, who was that had questions?
Radio Shack.
I should have known that. Except they didn't have answers for years. That's why they're gone.
Yeah, true. Yeah, when they did, finally, it was the wrong answers. So.
Yeah.
All right, well, I guess you can ask me this one.
Okay. What is a beta or hairpin match? A. It's a shorted transmission line stub placed at the feed point of a Yagi antenna to provide impedance matching.
B. It's a quarter wave section of 75 ohm coax in series with the feed point of a Yagi to provide impedance matching.
C. It's a series capacitor selected to cancel the inductive reactance of a folded dipole antenna.
Or D. It's a section of 300 ohm twin lead used to match a folded dipole antenna. What is a beta or hairpin match? You know, this is just one of those you're going to have to know what it is. It's going to be hard to reason it out.
If you saw one, you would probably know what it was.
Yeah. If you just happen to see a shorted transmission line stub placed at the feed point of a Yagi antenna to provide impedance matching, then you would know
that was bent sort of in the shape of a hairpin.
Yeah, that it was a beta or a hairpin match. Let's see if that's right. It is. Everybody over in the chat room has apparently seen one of those before.
Mm-hmm.
Which of the following antenna types will be the most effective for near vertical incident skywave antenna for short skip communications on 40 meters during the day?
Mine.
A horizontal dipole placed 1/10 to 1/4 wavelength above the ground.
B, vertical antenna placed between 1/4 and half wavelength above the ground.
C, a left-handed circularly polarized antenna.
Or D, a right-hand circularly polarized antenna. Near vertical incidence basically means that the horizontal antenna so close to the ground that it basically reflected nearly straight up, near vertical, which is unfortunately not by my preference, but that's basically how my antenna at home works.
Yeah.
Because I can't get much height on it. So I'm thinking the answer to this one is going to be A horizontal dipole placed between 1/10 and 1/4 wavelength above ground. If you want to see one, come look in my backyard.
Yeah, that's everybody's agreeing with that over in the chat room. I'm going to say you're correct on that too. It's a horizontal dipole close to the ground. All your signal's going to go
Nearly straight.
nearly vertical. So it's good for close-in talking, you know, not too terribly far because it's coming straight up and bouncing right back down right around your region.
Yep.
Not so good for DX though.
One day I'm going to do something about that. I'm not sure what it's going to be yet, but one of these days.
Okay.
What is the feed point impedance of an end-fed half-wave antenna? A, very low.
B, approximately 50 ohms.
C, approximately 300 ohms.
Or D, very high.
Is that exactly very high or just a little bit very high? Or is it very low?
Well, I don't think it's 50 ohms approximately.
No.
And I don't think it's very low because usually when the antenna is too short for the frequency, the impedance will be very low. So that's going to narrow it down to, I think, either approximately 300 or very high. And I'm just going to take a stab at this one and say very high.
Yeah, I would think that's the answer too, because approximately 300. But what does very high mean? Let's see if that's right first.
Okay. Very high.
So how long is that piece of string?
They were a little mixed on that one in the chat room there too. Yeah. I can't tell you how long that piece of string is, but I can tell you if a piece of string has one end, it usually has another. You can take that to the bank.
Okay.
Very high. Yeah, I don't know how high.
Apparently over 300 ohms.
Yeah, must be.
Which I guess that would be high.
Yeah, I've never used an end-fed halfway, but I know a lot of people do. So, very high. In which direction is the maximum radiation from a portable VHF-UHF halo antenna?
Uh-oh.
A, broadside to the plane of the halo.
B, opposite the feed point.
C, omnidirectional in the plane of the halo.
D, toward the halo's supporting mast.
Should I get the buzzer ready?
Probably. Which direction is the maximum radiation from a portable VHF-UHF halo antenna? Broadside to the plane of the halo. B, opposite the feed point. Omnidirectional in the plane of the halo. D, toward the halo supporting. I think it's going to be C, Charlie. Omnidirectional in the plane of the halo.
Well, there are most people are saying that. I'm going to agree with you. Omnidirectional in the plane of the halo.
I almost wanted to pick A, but it's just the wording. Didn't, so C, omnidirectional.
Okay.
How does a screwdriver mobile antenna adjust its feed point impedance? A, by varying its body capacitance.
B, by varying the base loading impedance.
C, by extending and retracting the whip.
D, by deploying a capacitance hat. How does a screwdriver mobile antenna adjust its feed point impedance? Well, I just happen to have a screwdriver mobile antenna.
Yeah.
And I love it. I really like it. It's
You could probably use this to demonstrate your...
well, I could. This one is not a screwdriver antenna.
No, but the principle
But
is
the
the same.
principle is the same. This is a Wolf River coil right here. And on my screwdriver antenna, of course, there's a whip coming out the top. Then there's a
It'll be coming
coil.
out that end.
And then this, well, yeah. There's a whip coming out the top.
The other top.
And the bottom, of course, is the base of it where it's mounted. There's a coil here in a screwdriver antenna. There's a tap right here. You see this wire that's going around? There's a tap inside here that shorts out a certain amount of that coil. Like right now, everything from here down is shorted out. It might as well just be non-existent, or one turn, because that's how long that is there. So for the lower bands, you're going to want more turns on that coil. So you're putting more coil in it. It's making the antenna appear longer than it actually is. A coil is an inductor, and this is at the base of the antenna, so I'm going to say by varying the base loading impedance. So, yeah, you know, this right here,
Or how about the base loading inductance?
inductance, yeah. If I read it right, that's what I would say. But I would say it's B. And, yeah, that's a coil's inductance, so we're changing it. Screwdriver, actually, I think there is such thing as a manual screwdriver.
Probably so.
But, you know, typically, you know, it's a motor that's adjusting that tap up and down the coil there. So let's see if I'm even right. By varying the base loading impedance.
Inductance also.
Yeah, if I could say it right, I would be right on that one. Let's see. Oh, well.
And this was not a plant, by the way. It just happened to be there. I see it every time I sit down. It's been on
Yeah.
the bottom shelf like there for like
Yeah,
a year.
why don't you put it back down? This is a really good one, too.
Yeah, oh yeah.
And I have some 102-inch whips that I bought at Radio Shack when they were going out of business that would fit that perfectly, and I need to just go ahead and build an antenna out of it.
Yeah. Oh, that'd make a nice segment too.
Yeah. In which direction or directions does an electrically small loop less than 1/3 wavelength in circumference have nulls in its radiation pattern? Is it A, in the plane of the loop,
B, broadside to the loop,
C, broadside in the plane of the loop,
or D, electrically small loops are omnidirectional? Which direction or directions is electrically small loop less than 1 have nulls and the radiation pattern in the plane of the loop? I am going to say in the plane of the loop.
Okay.
I'm guessing. I don't really.
Okay. Well, nobody said that in the chat room, but they guessed everything else.
Okay, so then I probably just got a buzz.
And what
I
are
was right. I said broadside to the loop.
No, I don't think that. I think you said zzz.
yeah, that's what I said.
So that was the last question. What a great way to end our 2019
I
classes.
got buzzed the last buzzer of the year.
Well, you know, a lot of students get buzzed, but I guess a dean does occasionally too.
Well, you've seen those hot tub pictures.
Yeah, true. Broadside of the loop. Well, you know, it had to be either the plane or the broadside.
Yeah.
So if you've got a loop, an electrically small loop, then if I wanted to point it at the camera, I would turn it like that, because the nulls would be off either side of it. Is that correct? That would be in the plane of the loop?
I would think so.
Yep. And if I turn broadside would be like this. So now I'm nulling the audience. They cannot hear what I'm saying if I was on a radio.
Okay. So I guess I was thinking about it a little bit backwards. Because I was thinking more of the line of the one that you had in the back, or I guess it's still back there, that runs around
Yeah.
the yard this way.
Mm-hmm.
So
That's a horizontal loop.
yeah.
So
Interesting.
is the broadside the side I'm pointing to the camera, or is it like that?
Yeah, the broadside would be.
I think it's like this.
Yeah, that would be the broadside.
I've got a loop, electrically small loop right over there, but I just can't get to it right now.
Yeah, me either.
But it's not optically small enough that we could turn it here in the camera and you could see it all at the same time. Anyway, I want to thank you for pulling that off for us tonight. We were about to lose street cred there.
Well, somebody had to take one for the team, man. So since
Yep.
it was the last one for the year,
Well, I appreciate you doing that.
you get to get the first one for next year. How about that?
It's possible. It is possible. Well, boy, we've just finished every question in the general pool, including the ones that changed this year. The ones that were added.
We were finished.
Significant change.
Everybody enjoy your break.
Yep.
Be ready for class when we come back.
In
Classic.
January, end of January.
Yeah.
And let me just say, in addition to what you've studied right here on Ham College, you can go to hamstudy.org and take practice exams online. You can go to the real professor, Gordon West, WB6NOA, our friend Gordo, and get his study guide, which I think is probably one of the best that's out there.
Oh yeah.
Or you can, if you had one handy, well, that's not it. That's Gordo's old book. And I had one handy before the show tonight, but I don't know what happened to it. ARRL also has a general study guide that has just been updated. Yeah, here we go. Theirs are available too if you want to use the ARRLs. They've got a general Q&A manual with the newest general question pool in it. It's available as either, a paperback style, or you can get it in a bound, spiral bound style here as well.
Okay.
A little bit bigger print in it. So there's your 3 printed choices right there, the traditional way to study for your exam. And, whatever you use to study for, we do hope that you used the information here on Ham College, at least the questions that we gave you the right answers for.
That's always a
Yeah.
good bet.
But we want to wish you good luck in taking your exam, and let us know. If you studied here at Ham College and you passed your exam,
if you're a
let us
graduate.
know. If you're a graduate, yep.
Yeah, let us know. We've got quite a few emails from Ham College graduates. So
We have.
great to hear.
What do you say we just do a quick run through the chat room here and say best 73 to everyone that's in there tonight. A lot of good friends in there. They've been having a pretty good time, and I haven't been able to watch it because a few of these have been kind of tough tonight. Oh, I did notice, though, that Marty said that a friend brought him a Wolf River coil
Oh, cool.
in November. He was in the hospital, so I don't know. We'll have to catch up with Marty.
Yeah, I saw these guys at the Hamvention before. They got some pretty cool stuff.
Oh yeah, I can't remember his name, but I've talked to the guy who makes these.
Uh-huh.
We used to do Google Hangouts.
Oh, yeah?
I used to talk to him on there with Dan in non-LVS.
Yeah, it's pretty nice. Good deal.
Yeah. Well, Spike says that Ham College keeps us polished up on our radio facts. Okay.
You know, it is, like I said when we first started, it really is good to go back and have a refresher on this stuff, because we've passed these years and years and years ago. Things change, as you can see.
Yeah, and like your memory.
Yeah,
that changes too.
That too.
So, yeah.
But the question pools are updated periodically to be just a little bit more current with what's going on, like the SDR things. And so it's good to kind of stay up on some of that.
It is. And, well, it's a big help for us as well, not just for the people who watch the program here. I'll say, you know, for those who aren't in the chat room, or, you know, that are watching live or watching a recorded version of the program, most of the people in the chat room that participate are hams. There's some that are not. So, you know, these guys are reviewing as we go along as well.
Yeah, but I know for a fact there are a lot of people that aren't. Well, we're on the general, but a lot of people that are watching now are technicians wanting to get the general. And just like there's a lot of people in here that are saying, not just in the chat room, but we've had emails and people mentioned it too, that when you're going to start on extra, because they want to follow along for that, MEL even is one of them.
Yeah, I would say there's a good many viewers that are going to need to pay better attention when we get to the extra, because
there's a good many of the hosts that are going to have to pay better attention too.
And we're going to be doing a lot of arm twisting on that one to get people to take that exam, because it is it's a little tougher.
It's tougher, but I did it, so anybody can do it. Don't let it scare you. You just have to kind of hunker down and want to do it. So.
Well, I did it too.
But it is,
But yeah, it was tougher.
But you can do it though.
And there was a lot more buzzer action going on when I took that than you see on the typical Ham College episode here. Oh yeah. Well, Happy New Year, everyone over in the chat room, and those of you watching live and those watching the recording. And if you're seeing this before January
Thirsty?
Yeah. See, I'm thinking about New Year's already. If you happen to be watching before January 1st, well, why don't you come join us on Tuesday, December 31st at 9 Central Standard Time, 0200 UTC for what?
Oh, the live stream, the New Year's Eve celebration.
The New Year's Eve celebration. I don't have my list back here.
And we don't have like a crystal ball that's going to drop or anything at midnight, but it's going to be a good time. I can assure you that. Right.
We're going to drop a gold PL259.
Yeah, we might have one or two of them left.
No, I would tell you some of the folks who are going to be here. I know that VE3MIC will be with us, and Email will be with us. And, well, we've got a number of other folks lined up, some who have not, I haven't heard back from yet. But we're just lining up a variety of folks. There's no particular subject or topic. It's just going to be a gathering of friends and viewers, and we're just going to have a good time and talk about ham radio stuff, technology stuff, and a little BS in the process.
Probably be a lot of that.
Well, you know,
I guarantee you,
it's hard to miss the opportunity. But yeah, you know, Mike's going to be there. He's already scheming on some things.
Oh yeah.
And I hear Rockin' Ray's going to be here.
That'd be great. That'd be awesome. I don't think he's been on for one of the New Year's.
No, he hadn't. So
that'd be good. It'd be good to talk to him.
All right. So thanks for being here tonight, everyone. And as I said, good luck on your exams there.
Yep. Yeah, good luck. And be safe on New Year. If you're out drinking, don't drive. And,
Yep.
73.
Yeah, if we don't talk to you before 2020, Happy New Year.
Happy New Year.
And we got through another one unscathed.
But the night's still young.